Okay, so the floor is yours.
Okay, thank you. Hi everyone, I'm Romain Pugin, and I'm a DevOps engineer at Swisscom, like I said, and today I'll talk to you about how we can crash a network in some interesting ways. So first we need to start a network, and while it's starting, I will quickly describe it to you. That's the network we will crash. It's, as you just saw, it's managed with container labs, so it's easy to deploy and to bring down. It's made of two different cores, one in green and one in orange that you see there, and there are two metros area that are attached to it on the sides. In each metro, there is a C device, green on the left, and it's the Docker container you see on the right. And the two Docker images you see are Ixia C containers. Those are traffic generator images that we use to generate traffic inside the network. The network should have started by now. No, not completely. So on the side to this network, we also have a Kafka container to which we will send the traffic information, and then we will gather all this information from Kafka and display it in different graphs like the Grafana you just saw when I was setting up my computer. It's still not started. It's slow today.
So the topic being chaos engineering, we start well.
Yeah. Oh, and now it started. So we should be able to start the Ixia flows if it agrees. And it seems it does not want to. No, it worked very well. So now we can also. Now we can, with Ixia, we can fetch all the data about the flows that we have, and we will push them to Kafka topics if it agrees to also, because it seems to be a bit not wanting to help us today. Is Kafka running at all? Yep. Better this way?
It will be on YouTube, so there you can zoom in.
I'll just relaunch the traffic and hope it works better this time. I don't know why it didn't want to. I swear it was working a half hour ago, so. I forgot the T.
That's the problem with live demos. You always pray to the gods of demo. Okay.
Oh, and now you see, okay, for some obscure reasons it didn't want to before, but now you see it's getting the traffic, and obviously the virtual machine on which it's running is a bit tired, and some traffic is already being lost. That's why you see the two big warns at the bottom. So I will restart the flows, hoping that the traffic actually flows and is not killed, because otherwise the rest of the demo does not work. No, it's not the right screen. I don't see my mouse. Can I just... Where's my mouse? There? There? Where's the... okay, sorry. Up. Nah. Stop. So, start. And now the traffic, still a bit of loss. Less than before. It will have to be enough. So now I can, see. So now that's the interesting part. That's probably not going to work because a container crashed, and when we relaunched it, it did not agree with us. However, this, that's slash. This script will gather the network topology, and then it will pick a device at random and say, oh, we're going to crash something on this device. And then he chooses something. It could be an interface. It can be a process like a BGP process, an ISIS one, anything. It will target it, kill it, and then here, since we have traffic loss, he will stop doing more chaos on the network so that we can analyze what happens and why this particular failure broke the network. If the failure that was incurred, you see here we don't have traffic loss anymore, so it started up again. He drawn the CE device on the metro side, and it will,
Device shut down.
we shut down the device. So this will theoretically, if it works, break the traffic. And once the traffic is broken, there's a feedback to this script, and he will just keep sleeping. The main advantage of all this is that with Container Lab, you can just relaunch the whole network as it was. It takes about 2 minutes. Yeah, you see on the right traffic loss, and here he will just keep sleeping forever since the traffic is lost forever. And then you can just bring everything back up in a couple of minutes and do a new test. So that's kind of the whole project that we have. That is working now. Obscure chaos.
Can you show the Grafana? Just to see what happened.
Sure. Can I? Yep. So here you see we had some traffic, and then that's when I just started the lab. We had some traffic, and by the time it's going to be updated, we'll see there is more loss.
You can. Yeah. So, let me talk to you about what just happened. Full screen. Okay. So, I always like to start with this slide. Why? The project is called Chaos Engineering, right? If you put back. Yeah. To present myself, I'm Eugen Serban, a DevOps engineer. Can you go to the other slide?
This
please?
one?
Yes. So here you can see how our network of networks looked when we started our project to modernize the network. So we had all this network. You can see it's 2022, so this is obsolete. The goal is to consolidate all this to a new modern network that is running on SRv6 with Cisco as a provider and Huawei for the second network, and everything gets orchestrated by NSO and API gateway and all the buzzwords. Not going to spend that much time on this. What I want to show you today is what you just saw. So what you saw early was we are simulating all the network that you saw on the right-hand side. We are simulating it using Container Lab and XRDs. Why XRD? Because that's why we are using in the network, but of course you can use whatever you want. And we have the XCS, which are not CE, but you can configure BGP on them if you want, or OSPF, or whatever protocol you want for CE. We are just using them for the traffic generator. The topology that you just saw there is not the actual Swisscom topology, because we are not going to show it live to the public. It's the topology that Roman used for his thesis. Can you next slide? Next slide.
Next slide, sorry.
Next slide, yes.
Da.
Okay, so this was the network. Next slide, please. Then what he did, he started the connectivity check. It was the script that you saw on the right-hand side in his iTerm. It's written in Go. And what it does, it connects to the XCRC. It configures the flow however you want. So this is parameterable. Of course, we hard-coded everything for the demo, but the demo gods didn't want to play nice with us, and still we had issues. And what this connectivity check does, it configures the XCRC to send the traffic. It checks if the traffic is flowing, and if the traffic stops flowing for a certain amount of time, which is
3 seconds.
3 seconds, it will publish a Kafka topic that the flow is stopped. Next slide, please. Then what you saw was the Shub-Nigurat script. This script, what it does, it connects to an orchestrator. Actually, we want to have two orchestrators, one orchestrator for the network, which is the actual orchestrator, and one orchestrator for the hardware part. Anyway, what it does, it connects to the orchestrator and it interrogates it what kind of destruction it has. So in our demo, we hard-coded device shutdown, process crash, so it will crash ISIS or BGP, and interface shutdown, which, yeah, that one we excluded. So it will pick a process at pseudo-random because there are weights attached to every event. Next slide. And it will send it to the orchestrator. No? Okay. Anyway, the orchestrator, can you hear me? Yes. So the orchestrator in our network, it's Cisco NSO, because that's what we have to provision everything. And I created a package that connects to the network and does the process crash and everything. And we can add whatever we want. For example, we have a process that triggers a black hole in the network. Okay. Yes. Okay. Anyway, netconf is NSO is interacting with the network via netconf.
Okay. That's interesting.
Yes. So NSO is interacting with the network via netconf. If you look, I mean, if you look, you cannot look. If you remember, if you remember the slide, everything was modular. So if we want, we can take out NSO and replace it with Ansible, as long as it does the orchestrating part and it publishes the REST API to Shub-Nigurat. You can replace it however you want. Okay. We were at the orchestrator, yes.
This one?
Yes.
Sorry.
Okay. Now, next. Next is the Grafana, because we want to see what happens in the network. When you have a fault in the network is created in such a way that there can be plenty of faults. At some point, we trigger 16 faults like process shutdown, interface shutdown, device shutdown, and the network could still provide the service. As a service provider, that's what we sell, so we stop the test when the service is down. But in the meantime, stuff is happening in the network, and we have the Grafana to visualize everything, and we have GNMI to capture all this. So what GNMI does, it will subscribe to different things in the network that we would like to check. For example, interface traffic, micro seeds, BGP neighbors, all kind of stuff. And actually, there are two GNMIC, one for Grafana and Prometheus. So what it will do, it will write all the data into Prometheus, which is a time series database, and Grafana is used to visualize everything. And the other one is used to publish it to Kafka. Yes, GNMIC, the way we are using it is not on change, because for some reason the vendor that we are using doesn't really like that, so it's fixed interval when it's interrogated. Next slide. Next is Kafka, because everything is disaggregated. When we want to add new models in our test, we don't have to rewrite this or rewrite the connectivity check. Everything publishes useful information to the Kafka topics, and the other systems can take them from there and use them. For example, when the connectivity checks publishes stop, the Shub-Nigurat will see that the connectivity is lost, and it will stop the test, and then you can interrogate, you can go in the network and see what actually happens. And the last thing that we are missing, because we are network engineers, is the result analyzer. We have thousands of data points, and the goal of this is to analyze everything using, I'm going to use a buzzword just to, bump my ratings on YouTube. We are going to use AI, but it's, just machine learning to analyze what happened in the network and correlate when the service was lost, what actually happened in the network, what happened in the network to trigger the traffic loss. Next slide. So this is how everything looks. Now, the use cases. The first obvious use case is a flight simulator. We can give this to our ops team. Of course, it can, in our case, it runs on a virtual machine, and we can multiply it as long as we have computing power. And we can give it to our ops team, and they can troubleshoot, because the fault will be at random. So it's closer to real world when you troubleshoot something that you don't know anything. Then it's a flight simulator to validate our monitoring systems. Next, now it's stress testing. We are introducing so many issues in the network that our hope is we can find corner cases that Cisco or Huawei or other providers didn't take their devices, and we can find corner cases when bugs happen. And we can also test our reliability enhancing procedures. I'm not going to tell you what this is, because you can find it on YouTube if you look for SRE at Swisscom, and it's presented by our colleague Romain Bonjour. And the last use cases is fuzzy testing. When the network is orchestrated, everything should be validated, but there are so many input variables that we cannot validate everything. So what this does, it will just issue random configuration in the network, and we see if the network either crashes or it refuses that configuration gracefully. And that's it. Yeah, this is our North Star. Next slide.
Thank you very much.
Questions?
Any questions?
I forgot to mention that the plan is to open source everything that we had. So if you like something that you saw there, you can take that module and use it and play with it or do whatever you want.
Do you already have like GitHub repo or something? So you
Not
could,
yet.
Not yet. Do it now, then you can put it to the PDF.
Yeah.
Okay, question. I'll come to you.
Thank you for your talk, Will, again. I think OVH did exactly the same thing to stage their network, and they did a talk about that at the last RIBE meeting. And I suggest all who are interested about that topic to go and look at that, because it was really, really cool. And that's really, really cool. And if you open source, that's great. Thank you very, very, very much.
Yeah. Anyway, we didn't reinvent the idea. There are plenty of people that are using chaos engineering in their network, the most famous one being Netflix. But we are not allowed to use this in production because,
Do you do some, sorry, I'm Benjamin, hi. Do you do some really more controlled chaos where you will test by iteration, okay, we will stop this interface, check what it does, kill this process, check what it does, etc., and then like return all the scenarios in which it caused an issue, like killing this process here and killing this interface there, that kills the network, whereas killing this interface and this interface doesn't do anything.
Yeah, so this kind of controlled chaos, it's something that we do in our normal testing, functional testing. But the idea of the result analyzer is exactly this: get a snapshot of what we did exactly to kill the service. And then we go back and we manually trigger all that to reproduce it.
Okay.
One last question. Okay, no, then thank you very, very much.
Thank you.